Hello, this is the data structure and algorithm course, and I would like to discuss the solution for the mid exam. As you might know, we have the problem sheet separately from the curriculum, so you can take a look on the your file, so the PDF file given during the mid exam. So this mid exam asked you to do the code in Python, and there are three problems. And if you still remember, you need to do at least two problems out of three. But if you can do with the three problems, that will be also good, because I will put the additional bonus or the additional points to the other section of assessment. For example, for your quiz or for your assignment. So let's discuss one by one about the mid exam. In the problem number one, you have the problem about how a supermarket would like to apply a new discount program. And this is a kind of accumulation discount. If your purchase is more than 100,000 won, then the discount will be 10% plus 10%. So after you get 10%, then you need to calculate again the other 10% after you got the first discount. Okay? But if your purchase amount is less than 100,000 and more than or equal to 50,000, then you will get discount 10% and 5%. Otherwise, the discount will be 10% only. So this is a kind of if problem. And yeah, just a simple calculation. You need to calculate with the discount. And the problem here is write a Python class. And the Python class should be the name of customer. And there is one argument. Yeah, basically you can create any class with any argument, but I can say that it's enough with only one argument. And the Python class is supposed to help the supermarket doing P plus P program. Okay. So this Python class should be analyzed also with the big O notation. Now let's check how can we do this one in the curriculum. So you already know that we have the curriculum environment, and when you are doing with your problem, you have this environment. Now you can just think that here is one class and you have one argument. So this argument is about the purchase amount, and yeah, you can create a class, and the class name is customer, and then yeah, you can make the constructor. Okay, so the constructor will be the init self. Let's say I make a new variable a for the argument, and then yeah, I would like to create one attribute. Okay, and this is equal to a, and then I want to build the function. So you can see here we have one class and one argument, one class and one argument, one class and an argument, and then you need to make one function. Okay, we need to make the get payment. So the get payment means you will apply the discount program, and then you will get the final amount. In the problem sheet, it seems it's complicated, but of course you can do with any calculation. You can try to figure out how is the best way to calculate and how is the best way to get the final result. So I just want to simplify, and some of you know the problems well, and you can get the idea from this one easily. And I just want to give you the simple way to calculate. So if the self amount is greater than equal to 100,000, then let's say I have like yeah, maybe AM, okay, and then I will just calculate this with 0.9. So I know that the discount will be 10%, and after I have the first 10%, I need to calculate again with the other next 10%. Okay, so that's the only way to, that's the easy way to calculate the discount. Okay, and then if we have another condition, so you can just use this self amount. If the amount is greater than 50,000, then the amount will be self amount, and then we multiply with 0.9, and yeah, we have another 5%. Okay, and then yeah, we have the other condition. So in this case, yeah, we just want to get only 10%. So just multiply the amount with the 0.9. Okay, and after that, don't forget that it is a return function. So when you call this one, it should return one value. And I can just put a return here to get the value. Okay, so if I run this, okay, this is the result that you need to show in your Python file. Okay, so let's move on to the second problem. Okay, in the second problem, problem number 2, we need to write a program to make a Fibonacci. Okay, so the Fibonacci is the extension of Fibonacci. If you still remember, in one section of our uh, section in the PowerPoint, there is one function about the Fibonacci. So Fibonacci is a number that you will have after the other two earlier numbers. But now it is Fibonacci, means we need to consider three numbers. So the result of 3 here is from 1 plus 1 plus 1. So there should be three numbers or three earlier numbers to get the result of the next number. So for example, 5 will be from the 1 plus 1 plus 3. What about 9? 9 will be the result of 1 plus 3 plus 5. So three earlier numbers will be considered to calculate the next number. Okay. Now, how can we apply this one? So this one is same with the Fibonacci, but we need to consider only additional one value. Okay. So I give you this one, show the big O notation, and then use the print and this one is to show the result in the same line or in the horizontal way. So let's see how can we do this one in the Kuram. So when you are in the Kuram, you will see that this is a Fibonacci 8. Then you need to make one class, or yeah, you can make a function, that's also fine. We can just make the def, I think yeah, just a function, this one is enough. You don't need to create any value in the constructor, but you just need to run this function. Okay, so let's just make this as Fibonacci, and then let's make this one as n, and I want to define, because the original value should be defined, then you can define like this one. For example, file 1, file 2, and file 3, and all start with 1. Okay, so this is just to represent with the the same with the problem sheet. So we have value 1, value 2, value 3, and then we have the 4. We can look from the I is from the 0 until the range. Okay, and then yeah, you can design your code as you want. Someone want to use the recursion, that's also fine. If you want to use the loop function, that's also fine. Okay, if I is less than 3, okay, then what will you do? Because the n here, you can give any numbers. Okay, so let's suppose if it is less than 3, of course you cannot do all the numbers. You do not do the additional part, but you can just print this one with you just print the 1. Okay, so this is the simple way. If you want to do this one, you can have the more complicated way, but I just want to give you the solution in the simple way. And then if it is not less than 3, it means you will do something. Let's say I have the temp. mm, yeah, let's see, this is the temp. I have the temporary variable. So I would like to put the file 1. Okay, because whenever you like loop, then the value 1, value 2, value 3 should be arranged properly. So you can get the result with the function. For example, like this one, I would like to update the value 1. Okay, and the value 1 will be the value 1 plus value 2 plus value 3. So once I updated, once I put the value 1 into the variable temp, then yeah, you can put another value to the value 1, and then update the value 3 with value 2, because I want to update every of the number, and then update the value 2 with the temporary variable. And then yeah, after this, you know that every time you do the additional, you can make with this value 1. So yeah, this is the way to do the Fibonacci. You may have another way, that's also fine. Let's see. Okay, so you will get the result 1, 1, 1, 3, 5, 9, 17, 31. Okay, so this is the problem number 2 in the mid exam. Now let's take a look on the problem number 3. In the problem number 3, the problem is about how to calculate the distance between two lists. So we have Q and P, and then we need to calculate the Euclidean distance and the Manhattan distance. So the Manhattan distance and Euclidean distance formula is given like this one, and then you need to yeah, this one is the detail. If you are using the Euclidean distance, then you will do the uh, difference for every point. So this is the index 0 and index 0 of the other variable, and then you will do the square, and then also 6 minus 2, and then you will do the square, and so on. If it is a Manhattan distance, you will just need to uh, subtract. So 3 subtract 4, and then you just do it the absolute. So we want to get the positive value. So for this problem, yeah, you need to think a little bit more how to write the Python code. And I give you some hints here. You can use the A star star 2 to understand about the exponent 2. And then you have the star star half. It is about the square root. Okay. So the square root, you can just do with this one, or you can use the math.sqrt. So let's go to the Gurum. How can we solve this one in the Gurum section? Okay, so this is the Kurum part. You already know that we are having two lines. So the first is the Q and the other is P. And those are the given numbers. Let's say I would like to make a kind of variable equals to I, and I, let's start with 0. And then I would like to make a new variable. Maybe this is just for the easy way to explain how to make the subtraction. Okay. So R is a new list, and then I just want to make I which is less than length Q. Yeah, you can define any variable. If I is the less than length Q, then I would like to have the R. Okay, so the R, you want to add uh, every position in R with the element of Q, and then you want to minus with the element of P. Okay, so this is yeah, this is possible to do this one. So this is a kind of append. Okay, you can use append. Okay, some of you use append, that's also fine, but I want to give you a different way of the solution. And then once you can know the subtraction, then you will just add I with 1. Okay, so every time I is added with 1, then yeah, it will reach the length of the Q, and if it is already in the same with the length of the Q, then it will stop. After it stops, yeah, we can write something. For example, I want to get the input from the user, so choose a number. Okay. And then let's say I just want to, okay, maybe I just want to include everything in the one line. This one is Manhattan distance. Okay. And then the other is uh, the Euclidean distance. Okay. And after you have this one, I will need the if function. If the num equals to 1, then you will do something. For example, um, uh, okay, let me just give, maybe I can just have m. Okay, m is the Manhattan distance. Okay, and I will start the I equal to 0 again, and then I will use while I is less than length r. Oh, sorry. So we can have the m. M will be equals to the m plus the absolute of, we have the r. Okay, r is the subtraction. So because we know that this is the abstraction, so we can do the absolute for every of the r. And then after we have the summation, yeah, don't forget we need to add the variable with 1, and then we print the result of Manhattan. Okay, the result of the Manhattan distance will be m. Okay, but if we have the variable 2, maybe we can just have like else if, okay, if num equals to 2, okay, then maybe Euclidean distance. Let's make e equals to 0, and then let's start again I with 0, and then we have while again. Let's also start I until the length of the r. Okay, and then we want to create the e. Okay, e will be the summation of the total of the numbers. So we have the r again. Okay, but at this moment we want to get the r, and the r will be square, or it will be exponent by 2. Okay, so every of the r will be exponent by 2, and after you have this one, you can add I with 1. So if the I reaches the length of r, then we will stop the loop, and then we are going to print. Okay, the print is to show the result of the Euclidean distance, and we can just print the E. Okay, but after we have the summation, we need to square root. Okay, so square root is the exponent half, as we already see from the problem sheet. And yeah, maybe you will ask, how can we deal with the else? Yeah, this one is, we have if, and then we have else if. So I would like to have one more about else. Let's say this one is about the value error. Okay, so this is just additional. Okay, if you get, you do not, if you do not do this one, that's also fine. The number should be one or two. Okay, let me check. So you can choose a number. Let's say I will choose one. Okay, so the distance is 17. Okay, so this is the solution for the mid exam. Hopefully you understand the way to solve this one. I will not discuss the big O notation. I guess it is not that difficult. For example, in this case, the big O is ON because you will do the loop from the beginning until the end. Okay? And also for the Fibonacci, it will be also ON because you will do every of the numbers. And then for the first problem, I guess it's not ON, but it is just O1. It's constant because it just show how to deal with the if conditional. Okay, so this is the solution for the mid exam. Thank you very much for listening.